Hello, I am Paul and your instructor for this course. This course is entitled Reverse Engineering and Malware Analysis Fundamentals. If you are a complete beginner to malware analysis or reverse engineering, then this course is for you. I will show you everything you need to know to get started on malware analysis. We will cover the basics of every part of the malware analysis workflow from zero to proficient. From static analysis to dynamic analysis, unpacking malware to debugging, change analysis, behavior analysis, network analysis, reverse engineer and unpacking malware, identifying malware artifacts and indicators of compromise, and more. We will use only free tools in this course, including Ghidra. In this course, you will learn how to install the Flare VM virtual machine, which is one of the standard professional virtual machine containing all the essential tools for malware analysis and reverse engineering. You will learn how to identify file formats, understand PE header file formats, Windows API, perform static and dynamic analysis, do strings analysis, memory analysis, behavior analysis, change analysis, network analysis, how to identify standard and custom packers, as well as how to unpack custom and standard packers, and much more. This course is intended for anyone who has no background in malware analysis or reverse engineering and is just starting out in this field. It is also suitable for hobbyists who just like to learn how to analyze and reverse engineer malware. It is also for students who like to get started on the career path to become malware analysts or reverse engineers, and also suitable for all hackers looking for more techniques, tools and ideas to reverse engineer software. Some of the tools we'll be employing in this course include TreatNet, BinText, PE Studio, CFF Explorer, RedShot, FakeNet, Wireshark, Process Monitor, Process Hacker, Proc.dot, XDBG, Ghidra, and more. For taking this course, all you need is a Windows PC and an interest in malware analysis or software reverse engineering. By profession, I was a college lecturer and I've been teaching computer science and IT for more than 20 years. Thank you for watching, and I'll see you inside. Hello and welcome. In this video lecture, I will show you how to set up a lab for malware analysis. Why do we need to set up a lab? In the first place, malware can damage your computer if you execute it. So we need a lab in order to have a safe environment that we can use to analyze and execute and run malware. Also, a lab, a virtual machine actually, is able to be reset to its previous state. So after analyzing or executing malware, we can always reset it to its previous state. And the previous state are all snapshots. So we create snapshots before we analyze malware, and we revert back to the snapshot after we finished with the analysis. So let's get started. The requirements are as follows. We need to use a virtual machine creator to create virtual machines. And there are two popular ones, Oracle's VirtualBox or VMware. VirtualBox is free and you can get it from this link here. On the other hand, VMware has got two versions. The first version, VMware Workstation Pro, is a 30-day trial. Once the 30-day trial expires, you will not be able to use it any longer. The second version is VMware Workstation Player. It is free, but cannot create snapshots, so it is not suitable for our purpose. So either you go for VirtualBox or VMware Workstation Pro, which is 30 days, but I wouldn't recommend it because after 30 days you can no longer use it. So if you are going to go for free and not ready to buy the license for the VMware Workstation Pro, then stick with VirtualBox, which is free. So the download link is here, and this is the website where you can download. Just go ahead and click on the Windows host and download it. After downloading it, you will get and running it, you will get Windows which look like this. As you can see on the left panel, I have already installed several virtual machines. Next, you need to download an ISO image or Windows 7 Ultimate 32-bit version. Now the reason why we need Windows 7 32-bit is because Windows 7 has got a smaller footprint. You will find more samples targeting the Windows 7 machine. Second reason is Windows 7 machine is smaller in size and footprint and less resource intensive compared to Windows 10. And most malware is 32-bit, although there are also those targeting 64-bit. So go for the Windows 7 Ultimate. And then after that, you need to install the guest addition tools for the virtual machine. The guest addition tools allow you to go full screen and also allow you to share folders. Sharing folders is important because you want to transfer tools and files between your host computer and the guest virtual machine. Then we will look at how to create a shared folder to exchange files between guest and host, and also how to create a base snapshot of the virtual machine after configuring it. Next, we will look at how to configure the virtual machine. In this case, your virtual machine is your Windows 7 Service Pack 1 Ultimate 32-bit version. We will disable Windows Update, disable Windows Defender, which is the antivirus for Windows, disable hiding of file extensions, enable show all hidden files and folders, disable ASLR. ASLR is where the operating system randomizes the entry point for programs which are running. So we should disable it so that every time we want to analyze, we will get the same entry point for the memory addresses. Then we should also disable Windows Firewall, and finally create a snapshot. So the first step is to create a new virtual machine. After downloading Windows 7, you will have a file which quite long. It has got a .iso extension. The file size is approximately 3.8 gigabytes. So just rename it to make it shorter. I call mine Windows 7 Service Pack 1 SP1 -32-bit. And remember the location for this, where you put it. You can place it somewhere convenient for you. And then now we are going to go through the process of creating a new virtual machine. Click on machine and then click on new. And over here, give a name for it. Call it Windows 7. Windows 7 Ultimate SP1 32-bit. And then you can leave the machine folder default as it is, and then go here and look for the settings. Make sure it's selected as Windows 7 32-bit, and then over here click next, and this you can leave it as a default. If you have more RAM, you can increase the RAM size for the memory. Maybe you can put 2048, and then click on next. And then here no need to change anything, just click on the create button, and here click on next. Leave the default as it is, and here leave it as dynamically allocated, and click on next. And this should be fine as it is dynamically growing. Click on next, and now you can power it on. And now you select startup disk, so click on add and go and look for the new ISO image. ISO, go to the folder where you downloaded, where you place your ISO, which is this one, and hit open, and then click just click on it, and then now click start. And the installation process has begun. You will install it just like any operating systems for Windows. You will go through the whole process, and this will take some time. Just let it run, and once it has completed, we can install the guest edition CD. So here click on next, click on install. Click accept the license agreement. Take note, it's Windows 7 Ultimate SP1. Click on next, and click on custom, and then here click on unallocated space, click on next, and now it has begun copying file, so let it run. So I will just let it run now, and we will stop the video for now, and I will see you in the next lesson and continue where we left off. Thank you for watching. So now the virtual machine has rebooted and restarted, so you can key in a username if you want and click on next, and I'm going to leave the password as blank, and here is where you key in your product key, and then uncheck this one, do not activate, and then click next. If you don't have the product key, you can just skip and do it later. So in this case here, we just skip this now and just click skip, and then here click on ask me later, and here you can set your time zone if you want, and click on next, and just click anything we do here. I'll just select the home network. Now you can install your guest edition CD. So go up to the device here and insert guest edition CD. Next, open your computer, go to computer, and your guest edition CD is here. So double click on this to install, and select the proper one for your system, which is x86. So double click this one, click yes to run it, click next, and click next. So the path is over here, program file Oracle, and click next, and check on this box and click install, and then click on reboot now, click finish, so it will reboot the virtual machine. Now you can go to full screen view, so click on view full screen, if your virtual machine cannot go to full screen, then shut it down, and then come down here, select it, click on settings, and then over here select display, and increase this to 128, the maximum, and then here enable 3D acceleration and hit OK, and then start it again. Now you can go to full screen mode, and there you have it. If you want to restore back to Windows mode, just move your cursor to the bottom of the screen and hover it there, and this bar will pop up, and just click on this icon. Next thing you want to do is set up the shared folder. So to create a shared folder, first you go to your C drive, and then create a new folder, Windows Shared, REMA, or any other name you prefer. And then in here, select the virtual machine, and then click settings, and under the shared folders, under here click on add new shared folder, and the folder path, select other, and go and choose the file which you created, the folder which you created, this one, click on select folder, select auto mount, and then click on make permanent, click OK, click OK again, and now go back here, click on the file explorer, and you should be able to see your shared folder mapped as a Z drive. So this is where you can share files between your host and your guest operating system. So whatever file you put in here will also be available in your host and vice versa. So now the next item is to disable Windows Update. So to disable Windows Update, search for update and click on the result, Windows Update, and here let me choose my settings, select option, never check for updates, and then click OK. Because updates will detect new viruses and so on, so you don't want your Windows to detect the virus when you're doing analysis. So the next item will be disable Windows Defender. So to disable Windows Defender, over here, you search for services.msc. Click on services. Windows Defender is Windows antivirus. If you don't disable it, it will prevent you from analyzing malware. So scroll down and look for Windows Defender. This is the one. Right click on it and select properties. And at the moment it is set to automatic. So change it to disable. Click stop as well to stop the service. And then click apply. Click OK. So now you check Windows Defender is disabled. The next thing you want is to disable the hide extensions. So open your File Explorer, open any directory, and under here, organize, select folder and search options, select view, and then down here scroll down and uncheck this box, hide extension for known file types. So next one is disable hide extension, show hidden file and folder. So look for, check this to enable the show hidden file and folder. So now with these two settings, you'll be able to see the file extensions. So click apply, OK. So now if you go to any folder, the file extension will be visible. You can see .dll, .exe are all visible. This is important because malware sometimes masks its true file type. It could be an exe file and it will put .pdf, .exe, and because the exe is hidden, you thought it's a PDF file. It's a common trick. And also hidden files are not visible. You want to see hidden files because some malware will put themselves, make a copy of itself in some hidden file location, and if it's not disabled, you won't be able to see the hidden files. Next is to disable ASLR, which stands for Address Space Layout Randomization. It's a security feature that randomizes memory addresses used by executable code, including DLLs, so that it makes it harder to analyze binary files. So we want to disable that, so it makes it easy for us to analyze the binary files of the malware. So to do that, to disable it, we open a program called registry edit. And then we go to this location. HKLM local machine. So the registry is where Windows keeps all its configurations. So just open this and look for system, and then look for current control set, and then look for control, look for session manager, and then look for memory management. Click on it, and inside here we must add a new key. So just right click here and then new, and the key name is 32-bit value, dword, and give it a name of move images. The default is 0, so that is what we want. So this tells Windows not to move images. That means not to move the process when it's loaded into memory, but keep its original specified entry point when the programmer wrote the program. So that's it. So this will disable. So now you need to reboot the computer to have this take effect. The next thing is disable Windows Firewall. So right click here, search for Windows Firewall, or just type firewall and select this one, Windows Defender Firewall. The reason is because we want to analyze malware. Malware typically will call a control and command center or try to connect to a server on the internet, and we want to know where it goes. So we should disable it. Turn Windows Defender Firewall on or off, and here select turn off for both and click OK. Okay, confirm that it's turned off. Next thing you want to do is create a snapshot. So to create a snapshot, you can go down to the bottom, hover your mouse here, and go to your machine. So just hover your mouse at the bottom here, select machine, take snapshot, and here you can say, give the date if you want, 2021 for example, and the month and the day, and say fresh install, and then here's some description, configured, click OK, and it will create a snapshot of the state of the machine. If you want to restore, you have to shut this down first. Click shut down. So after shutting down, you can see over here there is a list of all the snapshots. So currently this is the snapshot fresh install, and you notice it has changed. If you want to revert back to fresh install, just select it and hit restore, and then make sure you uncheck this and click restore. Then it goes back to the previous state. As you can see from my earlier machines, some of my machines has got multiple snapshots. And if I wanted to go back to an earlier snapshot, all I have to do is just select the earlier snapshot, click restore. So this is useful for malware analysis because every time you run a malware, it will corrupt your files and registry and other things. And you always want to restore it back to the previous state before the malware was executed. And this is the workflow for every malware analysis session. And just remember to take a snapshot before you execute any malware and restore it back when you have finished. That's all for this lesson. Thank you for watching. To install Flare VM, first you need to create a virtual machine. Using Oracle VirtualBox, you install Windows 7 64-bit, and the setting is you give it 4 MB of RAM, and the storage you give it 75 GB storage. After you've done that, you start your VirtualBox and go to, if you want, you can install Google Chrome, and then use Google Chrome to go to this GitHub for Flare VM and download. Click this, download the zip file. You unzip the zip file into your C drive over here, Flare VM master. So this is where you put it. And then before that, the instructions on the Flare VM website says you can follow the instructions here, how to install. So over here it tells you the first thing you do is you need to download the zip file, uncompress it, and then change to the directory where you decompress the zip file, and you must set this execution policy unrestricted. That means you need to open your Windows PowerShell, right click your Windows PowerShell, and then right click run as administrator. It has to be administrator, and then once you're there, you go to your directory where you install, where you unzip your Flare. So let's go there. And then over here you have your all your files that you unzip, and then you execute this command, set execution policy unrestricted. Alright, you execute that command inside the PowerShell, inside here, execute the command, and then after that you can run the installation script, which is install.ps1. So this file, run the script, install 1.ps1. Before that, it says here that you need to update your PowerShell. So your PowerShell needs to be this version. You don't need to update net 4.5. You can try if you want. If it's already recent enough, current enough, then it will tell you don't need to update. But for this you need to, most probably. So you right click this and open and download. So when you click download, you get a few things you can choose. Choose this one. So after downloading this, you go to your folder download folder, unzip it, and then run this program, and it will update your Windows with PowerShell. And your PowerShell will be PowerShell 5.1. This is a command to check your PowerShell. So after your PowerShell is already updated, then only you execute the rest of the command which I explained earlier. So it's important to update PowerShell first before you execute any of these installation script. So it will take a few hours, I think, to install everything. So once you finish install, you get this thing on the desktop, and you must make sure you make a snapshot often. Go here, take snapshot, and then you snapshot. As you can see, I've got a few snapshots here. So that's all for this video. Thank you for watching. In this video lesson, we are going to start using your Flare VM tools. This is what it looks like after you have completed the installation of Flare VM. And there's a folder here. If you click on it, it contains some of the tools, and you can enter the folder and you see the shortcut to run those tools. For example, this is a hex editor. Other tools can be found here by clicking search and typing the name of the tool that you want. For example, Ghidra is here. Some of them are at the bottom. Your x64, x32, debugger, and IDA, and so on. So the first thing we are going to try is to try to understand what are files and file formats. A malware analyst deals with hundreds of files every day. All of the files on the system need to be categorized so that an analyst understands the potential damage that one file can do to the system. A malware analyst needs to be aware of the various file formats and how to identify them. So how do we visualize a file? One way is to use the hex editor, hexd. Let us try to create a file now. Now everything in the computer is in binary format. Binary means everything is in bits, zeros and ones. So every file in the operating system is consisting of zeros and ones, and these zeros and ones can be viewed in hex editors and other programs. So we can, for example, create a file. Let us try to create a file now, a text file, and call it hello. And then here just say hello world and save it. If we were to open this file with Notepad or any text editor, the program itself will interpret those binaries to mean something. For example, these are interpreted as the characters H, E, L, L, O, and so on. We can also use hex editors. For example, if I drag this into a hxd, I can see the same thing. But this time I get more information. I can see the binary files, the binary itself being grouped into bytes. So, and they are denoted using hexadecimal notation. And I can see here that 68 hexadecimal is the letter H, and 65 in hexadecimal is the letter E, and so on. And this is how you can visualize files. So from here, it's quite obvious that this is really a text file, as you can clearly see the text. These kind of tools are called hex editors. They allow you to view the raw format of a file by grouping the binaries, ones and zeros, into groups of bytes. Each byte is represented by hexadecimal like this. Another useful tool is TreatNet, which can be used to identify the file type. And you can download this from the resource section for this lecture. Just unzip the file and put them in the C drive as 05 treat and 06 treatnet. 05 treat is the command line version, 06 treatnet is the GUI version. And then after you have put it here, just right click the treatnet, drag it to the desktop and release, and create a shortcut here so that you have a treatnet icon here. And then make sure you also unzip the definition file, because it uses the definition files to identify file types. Now to use it, just open it, and then you can put the file you want to scan by dragging it into here like this. And then over here you need to specify where is the location for your definition file, and select the DF folder, and then let it scan the definition file. After it has finished scanning the definition file, you can analyze the target. Just click on this and it will analyze and shows you the percentage of match. For example, 83.8%, this is a Windows Control Panel generic file, 7% is an exe file, 4.5% is a Windows 64 executable, and so on. So from here you will know the file type here, and you don't have to rely on the extension or the fake icon that you are seeing. So these are some of the basic tools for determining file types in Windows. So that's all for this lecture. I'll see you in the next one. Thank you for watching. Hello and welcome back. I'm now going to give you an exercise. Go and download this sample lab from the resource section and put it on your desktop. Inside here you will find some example samples for you to identify the file format. Is this an executable file? Is it a text file? Is it a picture file? Is it a zip file or whatever? So use TreatNet to find out. And the way you do that is you simply drag the file into TreatNet, and TreatNet will scan for you, and it will give a result here to tell you how many percent match for the various result. So as you can see here, for sample 311, it is an executable file. How about the second one? Second one is a zip file. So we know that this is a zip file. We can actually rename this to become a zip file. Right? We can copy and paste it here and put a .zip behind, and then we can extract it. And there you go, it is a zip file. And you can see the contents. How about the third one? It is a PNG file, that means it's a picture file. So if it is a picture file, we can copy it here, and it's a PNG. So we put a .png file extension and open it with a picture viewer, Paint for example, or photo viewer. and there it is a picture file. So I leave the rest of the exercise for you to try on your own. There's something else I want to show you. There's also a command line version of TreatNet. It is in the C program where you put earlier on when I told you to put that. It is over here, treat. So this treat is doing the same thing as the GUI version. So let me show you how to use it. You can open a command prompt, clicking on the Windows icon, search for CMD, and then click on it. Now you open the command prompt and you just pin it to the taskbar. Right click and pin this program to the taskbar so that you can have easy access to it in future. And then you navigate to this location. So let's copy this path here and type cd space, right click to paste it here, and then press enter, and now you are in this location. Okay, so if you wanted to scan a sample, this sample on a desktop, you need to get the path to it, copy the path, and then over here run the command treat exe spacebar and paste the path to this location on the desktop. Put a backspace and then type the name of the sample, press enter, and it tell you what is the same result, but it is in command line form rather than the graphical user interface. So if you were to scan sample number 3, change this to 3, you should get the same result. It is a PNG file, see that? So this is the command line version of this. If you wanted to make this command treat available anywhere else in your file system, then you need to add the path to the environment variables. So how do you add this path to the environment variables? You just click here and search for env environment, edit environment variables, edit the system environment variables, and then over here look for the environment variables button, and under system look for the path, this one. So you want to edit this path, so click on edit, and then to the back of this path, don't delete anything, just write a semicolon, and then add the path to this program, to this folder, C05 treat. So C05 treat is like this. So just copy this and then append it to the back here and paste. Alright, so now you click OK. So now your Windows knows where to look for this program. So let's say I close this. After you have changed the environment variables, you need to close the command prompt and reopen again so that it can read the new environment variables. So now, no matter where you are, you don't have to go to this folder in order to use treat. You can just fire away from wherever you are. You can just type treat TRID and you should be able to run. See that? So this is how you add new path to your environment variables. So in future, if you download any kind of command line program and you wanted to access the exe from anywhere in your file system, remember to add the path to your binary, to executable, add it to your environment variable using the technique I have just demonstrated. So I leave you now to complete the rest of the exercise using the both or either one of these two here to familiarize yourself with the how to identify file formats. That's all for this exercise, for this video lecture. Thank you for watching. I'll see you in the next one. Hello and welcome to a new section. In this section, we are going to study virtual memory and the portable executable, also known as PE file. We are going to look at number 1, process creation. Then we move on to number 2, virtual memory, and number 3, portable executable PE file itself. Go ahead and download this sample lab 4, which are available from the resource section for this video. Inside it, you will find 3 sample files, sample 4.1, 4.2, and 4.3. So now we are going to study process creation. We are going to look at how a program is turned into a process by the operating system. So as an example, we are going to look at a C program. So let's consider this simple C program. This program prints hello world and then goes into an infinite while loop. And this is sample 4.1c. The samples are given to you without the file extension in order to protect you from accidentally executing it. So if you wanted to execute it, you will have to rename it and give it the .exe extension. So now we run it and you see it prints hello world. So this is the executable file that was compiled from the source code. So the program executes and prints the message hello world and stops there because it is inside the infinite while loop. Now we are going to examine this using a tool called Process Hacker. Open the Flare folder and go down to the Utilities folder and look for Process Hacker and run it. Process Hacker is used to study processes which are loaded and running in memory. So this is what you will see when you first launch Process Hacker. In the first column, you get the name of all the processes which are currently running in memory. If you scroll down, you can see sample 4-1 exe, which is this process which is running. Each process has a name, which is the name of the program from which it was created. The process name, however, is not unique in the list of processes. 2 or more processes can have the same name without conflict. Similarly, multiple processes from the same program file can be created, meaning multiple processes may not only have the same name, but the same program executable path. Therefore, to uniquely identify a process, each process is given a unique ID called the process ID, or PID in short. The second column shows you all the unique IDs for all the processes which are running. And you can see sample 4-1 has got the PID 1012, and there are no other PIDs with this number. So this makes this process ID very unique. However, if you were to run the program again, you will have a different PID. And this PID is randomly assigned to every process. It changes each time the program is executed, even on the very same system. Let's hover our mouse over it, and you can see the corresponding executable name, path, PID, and other information. To investigate the process in more detail, you can double-click it. It will open a new properties window, and there are several tabs in this window. We have the general tabs, which is the main one. You also have the threads, you have the modules, the memory, and so on. As can be seen here, the image file name is also shown, including its full path. You can also see the command line over here, the directory, when it was started, and so on. And it's also stated the parent of this process is the Explorer. And this is confirmed in the view here. The Explorer is the parent of this process. Now this is because we started this process using the File Explorer. This window here is known as the Explorer, and if we launch anything from here, it means that this is a child of this Explorer. Other things to keep an eye on are the command line parameters over here. The command line option shows the command line parameters provided to the process. While analyzing malware samples, it is important to keep an eye on the command line field, since some malware accepts the command line to operate and to exhibit malicious behavior. Without specific command line options, malware may not function as intended. So this may trick analysts and evade detection. So these are how you can use Process Hacker to analyze running processes. An important concept to remember is that before a process is executed and loaded into memory, it is a file in the hard disk. A file needs to be loaded by the operating system into memory and executed. Then it becomes a process. Before that, it is just a file. So that's all for this video. I will see you in the next lesson. Thank you for watching. Hello and welcome back. In this video lesson, we are going to study virtual memory. Computer systems have limited RAM, yet we are able to execute programs, processes which takes up huge amounts of memory. That is made possible by using something called virtual memory. Virtual memory allows a computer program to have huge amounts of memory beyond what the RAM, actual memory, physical memory is. Let's take a look at the concept in detail now. This is a diagram showing how a computer program executes. It involves three main components: the CPU, the RAM, which is your main memory, also known as a random access memory, and the hard disk. The program is stored on the hard disk, but for the CPU to be able to execute the code and instructions in the program, the operating system first loads the program into RAM memory and creates a process. The CPU then reads the instructions from RAM and executes those instructions. Today, RAM is relatively inexpensive, but in the earlier days it was quite expensive compared to hard disk. Virtual memory is created to expand the available RAM that is there. So virtual memory creates an illusion to a process, giving the illusion that there is a huge amount of RAM available exclusively for any process to use. This is made possible by the concept of virtualization or virtual RAM, virtual memory. Now in this diagram here, you can see that the actual RAM available could be just 1 GB. But because of virtualization or virtual memory, a process can access to 4 GB or even more for a 64-bit operating system. Not only that, multiple processes can be running almost in parallel, and each of them can be promised up to 4 GB, even though the actual physical RAM is only 1 GB, and they can execute in parallel without interference from each other. Now, how is that possible? This is made possible because the hard disk is used as a virtual memory. So the hard disk combined with the actual physical memory creates the ability to create virtual memory. So whatever is not sufficient, you will use a hard disk to act as a virtual memory or a virtual RAM. So take for example, we have two processes, process 1 and process 2. Process 1 may have 2 pages. A page is just a chunk or block of memory. So assuming process 1 takes up 1 page in the physical memory, and then page 2 is also loaded there. But then comes process 2 who needs to use 1 page. The operating system will swap page 2 from the physical memory to the hard disk. So page 2, which belongs to process 1, is still in virtual memory but swapped out to the hard disk. This is done so that process 2 can load its page into physical memory. And when process 2 finishes with its execution, page 2 is then swapped back into physical memory for process 1 to resume its execution. Now this is done so fast and seamlessly that the user does not notice it. So this is what makes it possible to have virtual memory, which is far bigger than your actual physical memory. We make use of the hard disk to create an illusion of huge amounts of available memory. Now let's do some practical. Go and download this if you have not done so. Sample lab. Now we are going to execute sample 4.1 and open it for inspection using Process Hacker. Scrolling down to the bottom, we can see sample 4.1 is in memory. If we double click on it, we will get more details, information about this process. Now go and take a look at memory. This is where you can see all the memory that is being used, the virtual memory for this process, sample 4.1 exe. Over here you can see the base address, and then in the second column you can see whether it is mapped, whether it's an image or whether it's private. And then in the third column you see the size of each of the memory block, and you can see the permission on the fourth column, read write or read write execute, or write commit and execute, and so on. For each one of these you can also expand and see the details inside here. Now what is the meaning of this? Private. Private means that this memory location is not shared with other processes. For example, stacks. Stacks are where a process stores its local variables. Also, when malware unpacks itself, it also uses private memory locations. So packers and malwares will make use of private, and also make use of the API called virtual alloc. So virtual alloc API usually unpacks the program into private memory location. Images. Images are those modules of the program. For example, the executable and also the DLLs. Memory location that contains code that executes, as well as dynamic link libraries are called images. We also have map. Sometimes parts of the files on the disk needs to be mapped into virtual memory for use by the process. So those parts of the memory which contain such data maps are called mapped. And the process can modify the contents of the file in a hard disk by directly modifying the mapped contents in memory. So map is just the pointer to the hard disk, so that when the process wants to access something, it goes through the map locations, which in turn references the hard disk. That is the meaning of map. Inside here, if you expand on this memory block, you can see commit, and some might have reserved, and sometimes you also see free. Commit means that the page have got a physical area in RAM allocated for it. That is the meaning of commit. If you see reserve, it means that it has not got the physical RAM memory allocated for it yet, but it is just being reserved. When the physical memory in RAM is actually allocated for this virtual memory, then it changes to become commit. And sometimes you will see free. Free means that those addresses are in virtual memory but has not been assigned or made available to the process yet. And then here you will see under the protection column, you have read, write, and execute. Read means that the contents of that memory can be read, but you can't write to those memory locations, nor can you execute anything in this memory location. Write means that the contents of that memory location can be read as well as written to. And execute means that that location contains code that can be executed or can be run. So when you see there is X there, it means that these are the locations where you can find code for running the program. Next, we will take a look at strings in virtual memory. The memory of a process has a lot of data that is consumed by the process during execution. Some of those data are human-readable strings like URLs, domain names, IP addresses, file names, names of tools, and so on. If you click on any of these memory blocks here, it will open the hex view. It will show you the raw bytes found in those locations. For example, when you double click this, it opens up this hex view, and you can see this location here, 4 followed by zeros, contains all these bytes and the magic byte MZ4D5A, which we'll be looking at next. So this tells you that this is a executable location because of these magic bytes MZ. This column here shows you the ASCII interpretation of these bytes. Sometimes you will see junk characters like this. This is because some of these are code, executable code, and some are even strings. For example, see, hello world is there. Now the first column is the offset of the data from the start address of the memory block. So when you see 0 here, it means offset from the address 402.000. If I went to this location and I open the hex view, 010 is offset from this address 4000, and here 000 is the offset from this address 401.000. Now the important thing to note is this column, which contains string. Even though some of these bytes are not really strings, but the hex viewer tries to translate it into human readable code, human readable strings. So you can actually search for string this way, but there is an easier way. You can use the strings button here. You can specify then minimum length and so on, and also search for strings in which region, and then click OK. And then it will search for you all the strings, and you can scroll down and look at the strings here, and you can filter out even. So using this technique, you can find a lot of information about the malware. Let's try it again. And this time we are going to add image. Alright, so now it has found more strings. And you can see, as I scroll, I can see hello world there, and this memory address. And then you can filter out further here, whatever you want to. You can use regex for regular expressions and so on, and strings containing what characters if you're looking for specific strings. Sometimes you may want to look for HTTP, and here you can see some HTTP here, and this might reveal some of the server that your process is trying to connect to. So we can make use of string searches like this and analysis like this to use against malware. So virtual memory, as you can see, analysis of virtual memory provides a lot of information for malware detection. Just by analyzing like this can also show you whether this is a malware or not. You can also get information about the malware name, hacker name, target destinations, URLs, IP addresses, and so on. So this is an easy way to detect and classify malware. So that is all for this lesson. Thank you for watching. I'll see you in the next one. Hello and welcome back. In this video lecture, I'm going to talk about Portable Executable File, also known as PE. PE files are Windows executable files. You can know whether or not a file is a PE file by opening it with treat. So let's analyze our sample. And treat has detected 90.7% that it is an exe file. So exe files are portable executable files. Portable executable files have a structure which looks like this. We have the mz-dos header, a dos stub, a PE header, section table, and the various sections. Let us use another tool now to study the PE file structure. Open up the Flare folder and open the Utilities folder and look for a program called CFF Explorer. Let us drag sample 4.1 into the CFF Explorer to open it. As you can see here, the PE file has several headers and subheaders, and some of these are collapsible tree views. The first header is known as the DOS header. If you click on the DOS header, you will see the various parts of the DOS header on the right. The first column is the member. It displays the name of the field. And the first field is called eMagic, which is the bytes 5A 4D in reverse. If you click on the hex editor, you can see it here. 4D 5A is the magic number, the magic bytes MZ. Whenever you see MZ, it means that this is a PE file. For sure, every PE file has this magic bytes MZ. If you go down further, you will see the text. This program cannot be run in DOS mode. And shortly below that, you will see PE. So these are positive confirmation. MZ and the string this program cannot be run in DOS mode, and the PE magic bytes. So these three things confirm that this is a PE file, a Windows executable file. So the DOS header here shows you the first two bytes, 4D5A. Why is this in reverse? Because on Intel systems, the PE is stored in little endian mode. Little endian is a convention for storing bytes in reverse order. The second column here is the offset from the start of the DOS header. And then the size tells you the size of the header. Word means 2 bytes. As you can see, 2 bytes, 2 bytes, 2 bytes. And then the value column contains the value of the bytes in those offsets. Next, let us talk about image base. When Windows loads a process into memory, it copies and loads a PE file and its sections from the hard disk into the process virtual memory. But first, it needs to allocate space in virtual memory. But how does it know at what location should it allocate the space in virtual memory to copy the PE files and its sections? This information comes from the image base field in the PE file under optional header. So as you can see here, the image base, and here is the value for that. Now let us open the file and run, and let's start our process hacker. Now if you scroll down, you will see sample 4.1 here. Let us double click and examine the memory, the virtual memory for this process. This process is now in memory, and we see from the CFF Explorer that the image base is 004 followed by 5 zeros. Now let's go to that location, and there you go. This is your image base. So this confirms what you see here, image base. However, this is not always true. Windows will load the value of this image base here as a recommendation. Sometimes it doesn't allow the use of the recommendation here. This can happen when the memory in the process virtual address is already occupied by other contents. So you cannot always rely on this recommendation here and confirm that it is here. Sometimes it might be in other locations. Other things of interest are the address of entry point, this one. The values shown in this column are relative virtual addresses, also known as offsets. So in short, we call them RVAs for relative virtual addresses. So when you see address of entry point at this offset 1040, if you want to find the actual location in virtual memory, you will take the base address, which is this value, plus this offset. That will give you 00401040, and that will be your actual entry point. Let us now try to check this with x32dbg. So just click on x32dbg. We will now close this program, and we'll use x32dbg to execute this program to debug it. x32dbg is a debugger. Just open it direct from here. Let us run to the entry point. True enough, it stops at the entry point 00401040. So this is confirmation of what we just did. The entry point offset is 1040. So to find the actual virtual address, you take this offset, add to the base address, image base, which is this, and that gives you this entry point 401040. Let us go back now to analyze the PE header. There are three main headers in the PE file: the DOS header, NT headers, and session headers. Session headers are here. Take a look at the DOS header. The DOS header starts with the eMagic field, which we have already discussed. If you scroll down this field right to the bottom, you will see this ELFA new. Now this bytes, this location shows you the offset to the start of the PE header. The PE header is NT header, this one, and you can view it in the hex editor as well. MZ, and then if you go down to this offset 80, you will land in the NT header. You can see here 80 at the 80 offset, you get your 5045, which is the PE header. So this is a DOS header, and this is your PE header, also known as NT header. So the DOS header is leftover from the days of the DOS Windows. This is to enable programs to be backward compatible. So if you try to run today's Windows application in the DOS mode, it will also run, but it will show this message: this program cannot be run in DOS mode. That is why Microsoft may retain this MZ DOS header. So when you run any Windows program today, it will just skip the MZ part, come here, look for the PE header, and execute from here. So the PE header is also known as NT header. The NT header is further split into file header and optional header. The NT header starts with this field 4050, which is PE in reverse, 5045 in reverse. Let's take a look at the file header now. The file header has 7 fields, 1, 2, 3, 4, 5, 6, 7. Let's take a look at the machine. The machine field tells you what is the processor for this PE file, the target processor, and here we can see it is Intel 36. If we double click this, we can change the type of processor, and you can see there are quite a long list here. But if you were to change to other processor, this thing will not be able to run anymore. because it's a wrong processor target. We'll just leave it as it is. Next field is the number of sections. So this field holds the number of sections present in a PE file. And here we can see there are 2 sections, 1 and 2. So sections, what are sections? Sections store various kinds of data and information in an executable. Some are code and some are data. Text are code. Code means instructions that can execute. And data means strings or constants or variables or structures. Sometimes malware, viruses, file infectors and packers modify programs by adding extra sections in here that contains malicious code and data. So when they do this, they also need to manipulate this field to increase it, to change the value here. Currently it's showing 2. Next is your characteristic one. We can double click on this to see more information. You can see that the file is executable, it is not a DL, and 32-bit program. Next header is the optional header. Although it is called optional header, it is not optional. It is very important. Windows will make use of this optional header when it is copying the file into virtual memory in order to run as a process. The 2 most important fields in the optional header, as we have seen, are the entry point, address of entry point, and the image base. Next will be your data directories. Data directories contains the size and the RVAs, relative virtual addresses or offsets, that contains important data, tables, and directories. Some of them are blank, 0, 0, 0, 0 as you can see, which means there's nothing. But some has got values. For example here, import directory, and this offset contains is in the data section. And another one here, import address tables directory. Next we look at the section data and section headers over here. The first column is a name. The name field contains the section name. As you can see, text and data. Normally, text means code that can execute, and data are those which contains data only without code. But this is not reliable. Malware can give it any name it wants. Sometimes you can also get executable code in the data section, so we cannot rely on these labels. The virtual address is the column here, is the RVA in which the section is placed in virtual memory. To get the actual virtual address, we need to add this to the image base, as we have seen earlier. The raw size is the size of the section data of the file on the disk. If you right click and select the change flag, right click and select change section flag, we can see more information. For example, I just right click on the first row and select flag, and I see that this section contains flags indicating it is executable, it is readable, and it contains code. If I right click on the second one, second row, and click on change section flags, I can see that this section is readable, is writable, contains initialized data, but doesn't contain any code. Hello and welcome back. Let us continue. If we click on any of these sections, we can see the data down here. For the data section, we can see the string hello world there. Windows will read the data in the sections here from the disk file and then make use of its raw address and raw size and copy them into virtual memory. However, when it copies all this into virtual memory, it makes use of the virtual size here. The raw size and the virtual size are not the same, as you can see. So when it's copied into virtual memory, you will notice it is different. We can confirm this by checking with Process Hacker. Over here, the raw address is 200, but when it copies this into virtual memory, it will take on a different address, and the offset is 1000. So when we come here, we can see, true enough, the offset is 1000. 4 is the base image address, as we have seen earlier. So we take the image base plus the offset and we get this address. Next, we shall take a look at DLL files, dynamic link libraries. Let's consider a program like this. Now, there is program 1 and program 2. Both makes use of helper function. It would be better then, since they are both sharing the same code, to create a DLL file out of the helper function so that they can share code rather than to repeat the helper function in each code. So if we were to take out the helper function and put it in a DLL file, we will get something quite different. Let's take a look. We will end up with something like this. So now this helper function has been factored out into a DLL file. So this is the meaning of DLL, dynamic link libraries. It has got a .dll extension at the back. A DLL file also uses the PE file format, just like the Windows executable file with the .exe extension. Similar to exe files, DLL files also holds executable code and instructions. If you click an exe file, it will launch as a process, but if you click a DLL file, it won't launch a process. This is because DLL files cannot be used independently and can only be used in combination with another exe file. You can use trick in order to detect whether a file is a DLL or an exe file. Another way is by using the characteristics field in the PE file format. If the file is a DLL, the characteristics field holds a value that indicates this property, and CFF Explorer shows this. Let us take an example. Sample 4.2. Let us run TreatNet and check sample 4.2. And you can see 10.3% says it's a dynamic link library. To confirm it, we can open it in CFF Explorer. Just drag it here. And now we open a separate tab for it. If you click File Header and click on the Characteristics field, you can see that the flag here says file is a DLL. So the CFF Explorer, together with your treat, confirms that this is indeed a DLL file. A DLL is just another PE file. So when executable PE file is about to run, Windows will load the DLL files first into memory. Windows will then check for the list of exported functions from the DLL files by referring to the import directory, also known as the import table. So if you go back to sample 4.1, click on import directory, you can see sample 4.1 needs to have msvcrt DLL. So if you were to now run samples 4.1 and look at the modules tab, let us open it with Process Hacker. Double click on samples 4.1. Now if you go to the modules tab, you will see that sample 4.1 makes use of this. So this confirms what we have just seen with CFX Explorer. So this confirms that this library, Microsoft C runtime library, is loaded into the virtual memory for the exe file sample 4-1. One of the things you might have noticed in the modules tab here is that there are many other DLLs in addition to this, but over here you don't see that. Now this is because of dependency chaining. Microsoft Visual C Runtime DLL file also has dependencies. It also needs other DLLs. So that is why we also see other DLLs here in addition to this DLL file. So together they form a chain. This might need kernel 32. Kernel 32 might need something else, and so on. And you can also use a dependency walker over here to check it out. Sample 4.1 needs this DLL, but this DLL needs so many others like kernel-based, NTDLL, and so on. And that is why you see some additional DLLs loaded into the virtual memory for this exe. So this is what we mean by dependency chain. Another important concept is IAT, Import Address Table. The question now is, how does the PE know which part of the DLL contains the function that it needs? It does that by something known as IAT, Import Address Table. Coming back to this example here, this program 1 and program 2 both needs to use the helper function that comes from this DLL. Let us now try the other samples. We are going to rename sample 4.2 as a DLL because we have just confirmed that it is a DLL. Now sample 4.3 is a exe, let's rename it. And it requires the DLL above. Let's close this one and run sample 4.3. So when it runs sample 4.3, we see this message helper function 2 coming from this DLL. Let us now open sample 4.3 in COF Explorer. And this one, we close this and load this DLL here. So now we have two files, sample4.3 and its corresponding DLL file. If you look at the sample4.2 DLL export directory, we can see there are two functions which are exported. And if we go and look at sample4.3 exe import directory, you see that it requires sample4.2. And then we click on it, we can see it requires helper function 2, which is coming from the export directory helper function 2. So this is how DLLs work. DLL has got the export directory, which is used by the exe import directory. And this is the offset to this helper function 2. Okay, so that's all for this lesson. Thank you for watching. Hello and welcome back to a new section. In this section, we are going to take a look at Windows internals. Malware misuses and manipulates operating system functionalities and features. A malware analyst needs to be aware of all of it. Operating systems and Windows internals are big subjects, but we need not know everything about it. We only need to know those common Windows internals necessary for malware analysis. So let's get started. The first topic is an understanding of Win32 API. API stands for Application Programmer Interface. It is just another technical name for functions, or a collection of functions. Win32 DLLs. Win32 DLLs are DLLs provided by Microsoft Windows. They are found in this directory called C Windows System 32. An example of such an API or function is known as kernel32 DLL. Kernel32 DLL contains many functions that are commonly used by application programmers and even malware authors. Let us try to open kernel32 DLL in CFF Explorer. Open up the Flare folder, then open the Utilities folder, and then launch CFF Explorer. Click on the Open folder, Open File, and navigate to this directory, C Windows System 32. Scroll down and look for kernel32.dll. Once you have found it, just open. Now let's go and look at the export directory for this DLL. At the bottom, you will see the list of all the functions that are exported by the kernel32 DLL. Close handle, for example, compare strings, copy file, create directory, and many more. Other DLLs provided by Windows, examples are ntdll, .dll, kernel32.dll, which we have just seen, kernelbase.dll, GDI32.dll, user32.dll, comctl32.dll, add vp32.dll, ws32.dll. There are also DLLs provided by Visual Studio SDK runtime. Examples are msvcrt.dll, msvbvm60.dll, and also a collection of VC runtime XXDLL. XX refers to the version of the SDK, and there is also the .NET frameworks, which is needed by C# and VB.NET to run. Next, we'll look at studying Win32 API from MSDN documents. One of the essential skills of a malware analyst is to be able to search for Win32 API documentation. We use Google for searching the internet for the API and MSDN. Try Googling create file MSDN and see what you get. Create file MSDN, and you will see a few results. This is the one you want. Here you will see a description of create file A function, and here is the parameter list, and below explanation of each of the parameters. Can use the MSDN to understand what a particular API does. Create file is not just for creating files. It can also read files. It all depends on the parameters passed to the function. API parameters govern functionality. Create file A accepts 7 parameters. The DW create disposition parameter decides if it is for creating file or for reading a file. This is the one. Create disposition. There are also ASCII and Unicode versions of APIs. Create file A accepts ASCII version of the string. Create file W accepts Unicode. Many other APIs also come in 2 versions just like this. Create file A is shown on the left, create file W is shown on the right. In create file A, the first parameter is lpcstr. In create file W, the first parameter is lpcwstr. W stands for white, meaning Unicode. There are also native NT versions of APIs. For example, create file A and create file W are provided by kernel 32 DLL, as we have seen earlier. Another version is NT create file, which is provided by NT DLL. It is much lower level because it is closer to the kernel. Both create file A and create file B calls NT create file internally. NTDLL then uses system calls, syscalls, to execute the task. Syscalls are kernel-level functions. Kernel-level functions are the heart of the operating system. Contrast this with user-level functions, also known as APIs, which makes use of kernel-level functions. Extended version of an API. Some APIs have an extended version. For example, Virtual Alloc EX is the extended version of Virtual Alloc. They are used to allocate virtual memory. Virtual alloc allocates virtual memory for the current running process. On the other hand, virtual alloc EX allocates virtual memory for other running processes. Malware frequently makes use of both of them, and also makes use of virtual alloc when unpacking itself. There are also undocumented APIs. For example, anti-APIs in NTDLL are not officially documented by Microsoft, but hackers have reverse engineered it and put up unofficial documents. Check out this link here. You can search by contents, by index, or just key in a search for an API which you want to investigate. Take an example of an undocumented API. NT-create section. NT-create section is an undocumented API commonly used by malware for a technique called process hollowing. So if you want, you can read about this NT-create section by going to the undocumented API here and clicking on search. NT-create section. And click on the result and you can read all about it. NT-create section. What is process hollowing? Process hollowing is a technique used by some malware in which a legitimate process is loaded on the system solely to act as a container for hostile code. At launch time, the legitimate code is deallocated and replaced with malicious code. The advantage is that this helps the process hide amongst normal processes. It is also good to be aware of APIs that are commonly used by malware. For example, APIs that perform file operations, create file, write file, read file, set file pointer, delete file, close file. APIs that perform registry operations, rec create key, rec delete key, rec set value. APIs for virtual memory, virtual alloc, virtual protect, NT-create section, write process memory, and NT-map view of section. APIs on processes and threads, create process, exit process, create remote thread, create thread, get thread context, set thread context, terminate process, and create process internal W. APIs on DLLs, load library, get address. APIs on Windows services, open SC Manager, create service, open service, change service config to W, start service. APIs on mutexes, create mutex, open mutex. Knowledge of these common APIs will help you greatly in trying to identify malicious behavior. Next, we will take a look at behavior identification with APIs. Behavior identification with APIs. Usage of APIs per se is not necessarily malicious. You need to analyze, number one, context. Number 2, parameters supplied to APIs. And number 3, sets of APIs used in sequence. Let us take the case of process hollowing. Example 1. Process hollowing. Process hollowing is a popular technique used by malware. It uses create process API to create a brand new process in suspended mode. To do that, it sets the DW creation flag to create suspended. Normal programs do not do that. This is an example of the create process API. So it sets this DW creation flags to the value create suspended. Example 2. Write process memory. This API writes into the memory of another process. Debuggers use this, so by itself, it is not malicious. But if a process, in addition to write process memory, also uses virtual alloc ex and create remote thread, then it is highly malicious. Therefore, the set of APIs used in sequence is what makes it suspicious. Using handle to identify sequences. Handle is a reference to files, registry, memory, and processes. Processes makes use of handles to perform operations on the object it refers. These handles are parameters which are passed to processes. Tracking or tracing these handles can help us to identify the sequence of APIs for any running process. And these sequences help us to confirm whether a process is indeed a malware. Let us take an example of the create file API. Examples of using handles, create file. And here are examples of 4 functions. The first one is create file, taking as the parameter here this text file called test1.txt for opening it for writing. And after opening this file or creating this file, if it does not exist, it will return a file handle and saved in this variable called hfile1. In number 2, it does the same thing, but this time it opens another file, text2.txt, also for writing, and if the file doesn't exist, it will create new file. And it also returns a file handle and saves it in another reference called hfile2. So we have 2 file handles here, hfile1 and hfile2. Now, can you identify the sequences? Tip: trace the handles. So first you take a look at hfile1 handle. When you look down here, you will notice hfile1 is also used in number 4, write file. Write file receives this parameter hfile1. So write file uses hfile1 to write to it. And the file that is being written to is text1 because text1 reference is hfile1. So sequence number 1 and 4 belong to the same process. Another example is hfile2. hfile2 is used here, number 3. So in number 3, it also writes to the file text2 using hfile2 handle. So number 2 and number 3 forms another sequence. So this is what we mean by identifying sequences by using the handles. This is a useful skill to have when trying to identify malicious behavior. So that is all for this lesson. Thank you for watching, and I'll see you in the next one. Welcome back. Introduction to Static and Dynamic Analysis. Malware analysis process. The malware analysis process can be generally divided into two main classes. First is static analysis, and second is dynamic analysis. The first step, of course, prior to this is to obtain the malware itself. And the last step will be to do the reporting after having done the analysis. So what is the difference between static and dynamic analysis? Static analysis is analyzing the malware without executing it. In dynamic analysis, we will execute the malware itself and then do the analysis. What is static analysis? Static analysis involves three things. It could be, firstly, performing a hash by using tools to obtain a cryptographic hash. Once we obtain a cryptographic hash, we can then look up the internet to see whether anybody else has already done a similar analysis. This is also how we can find out more information about any file. Because as we have seen in the previous lessons, you cannot rely on the file extension nor the file name in order to know what file it is. So the only reliable way is to obtain the cryptographic hash. Secondly, we can also analyze the embedded strings. So embedded strings are Unicode strings, ASCII strings, or even encrypted strings, or encoded strings. And thirdly, will be to analyze the PE header. The PE header will contain a lot of information, as we have seen in the previous lessons. So these three ways of performing analysis will give us a clue as to what the file does, what is contained within it, and we can get a good idea of what to look for when we later move on to the dynamic analysis. Some of the static analysis tools are as follows. We have ThreadNet. ThreadNet will be used to identify the file type. We can also do the same thing using execpinfo. From here we can know whether it's an exe file or DLL file or PDF file, zip file, or any other file types. Then we can go on to use bin text. Bin text is used for searching for embedded strings. The same is true for the strings. String is also a tool, a command line tool, which can be used to look for embedded strings. Another tool useful is XOR-search. XOR-search allows us to search for those encrypted strings in files. And it can reverse the strings that are found using SOR. it has got the XOR algorithm within it. The next one is CFF Explorer and PE Studio, and these two are mainly used to examine PE header, and we already seen how to use them in the previous lessons. And the last tool is HashMyFile. HashMyFile is used to create the cryptographic hash for any particular file. This is a screenshot of a static analysis session. On the top left, you see the treat tool being used to identify the file type, whether it's an exe file or DL file or whatever it is. And then here is exp info. This can be used to identify whether the file is being packed or not. For example, here you can see the file is being packed in UPX Packer. It can also give you information about the type of file as well. And then PE Studio. PE Studio can tell you what are the suspicious APIs that are being used by the file, and other information as well that can be obtained from the header, the PE header itself. PE Studio is created specifically to analyze malware, and it can look for suspicious files, suspicious fields inside the PE header itself. And down here on the left bottom will be CFF Explorer, and we have seen this already in the previous lessons. Next, we move on to dynamic analysis. Dynamic analysis can be further subdivided into two main categories: monitoring changes and also behavior monitoring. In monitoring changes, we will create a snapshot of the operating system before running the file, before running the malware. And then, once it has already obtained a snapshot, we will then run the malware itself, execute it, and let the malware run for a few seconds or a few minutes even, so that the malware will perform these changes to the operating system, like making new registry entries, creating new files, starting new processes, and so on, or even deleting files and so on. And once it's finished, after doing the changes, we give it a few minutes to do all its changes. We will then take a second snapshot. So now we can compare the two snapshots, and then from the comparison, we will know what are the changes made by the malware. So that's how we know whether the malware has created a new registry key and created any new files. Next is behavior monitoring. Behavior monitoring is where we will study in more detail the behavior of the running malware. For example, we can see if the malware has created any new processes, and whether it has written a new file, deleted any files, and so on. So those are the two main categories of dynamic analysis. Dynamic analysis tools. Some of the common tools used for dynamic analysis are Ragshot. Ragshot can be used to create a snapshot of the operating system before the malware is run. And then after running the malware, Ragshot can take a second snapshot and then do a comparison of the two snapshots, and will tell you which are the changes, what are the changes that the malware has made to the operating system. From there we can know if the malware has created any new keys in the registry, and we can also know what are the new files which the malware has created, and also other changes. Next tool is autoruns. Now, autoruns will be able to tell you what are the persistence mechanism which the malware has used. Now, it is typical for malware to try to survive a reboot of the operating system by creating new registry entries inside the registry, or creating copies of itself in certain folder locations which will auto start any programs contained within it. So autoruns will show you all those things. FakeNet. FakeNet is used to capture any kind of network connection to any outside servers. So FakeNet will pretend to be those servers which the malware is trying to reach, and that's how we can know what are the name of the servers, the URLs, and so on, which FakeNet, which the malware is trying to connect to. So FakeNet will not allow the malware to actually connect to the internet, because FakeNet will intercept those packets and fake a reply. And then FakeNet will save a file called a pcat file, which contains all the network connectivity connections, which we can then analyze using another tool called Wireshark. So Wireshark is very powerful. You can open the pcat file from FakeNet and we can analyze all the packets there in detail. Then we come to part1, also known as process monitor. part1 can be used to analyze all the APIs which malware calls, and is very useful. You can analyze whether it's writing the file, creating files, creating new registry keys, and deleting files, and so on. And then we can save this part1 session inside a CSV file. And then we can use another tool called part1 to open that part1 CSV file and draw a beautiful graph in visualization graph, which can then show us things which we are likely to miss if you are just using the text output from part1. So using part1, we can see what are the files which has been renamed, whether the malware has created a copy of itself and renamed it. We can also see what are the registry which are created in order to maintain persistence of the malware. And part1 also will show you the various threats that are created by the malware. So part1 is very useful for that. And there are other techniques as well. For example, reverse engineering, where we try to disassemble the malware itself to study the code, and the assembly code, or even the decompile code. Another technique would be memory analysis. Now, even though some malware may be packed in order to resist the analysis, but any malware that is packed, we need to unpack itself into memory, and that's where memory analysis can be used to defeat the packing. And finally, there's automation, where we make use of automation tools to perform the analysis itself. Now, the goals of all this analysis is to find out what are the file system modifications being made by the malware, what are the registry modifications, what network traffic is being generated, does it call home to download additional package, additional tools, and how does the malware auto start, and then finally, does it launch any other processes? So these are some of the questions we are looking for when you're performing malware analysis. So with that, we'll end this lecture here. Thank you for watching. I'll see you in the next one. I'm going to show you how to install two more additional tools, BinText and GraphViz. GraphViz is a library needed by part1, so we are not actually using GraphViz directly. So in this video, I will show you how to install BinText, and in the following video, the next one, I will show you how to install GraphViz. So go and download this additional tool zip file from the resource section, and then unzip it. After unzipping the file, inside it you will find two folder and one readme. So the readme will give you a brief description of how to install it, but you should watch this and the next video for better clarity. Now for BinText, it is very easy. Just unzip and copy the BinText 303 folder to the C drive. Then inside it there is a BinText exe file. Just create a shortcut on the desktop for this exe file. So over here there is a BinText, so you just copy this and then put it inside your C drive. So go to your C drive, put your BinText folder here. Inside it, you will see there is a BinText exe file. So just create a desktop shortcut as I've done here. To create a desktop shortcut, right click and drag and then drop it on the desktop, and then select create shortcuts here, and there you have your desktop shortcut. It is that easy. So that's how we install BinText. In the next video, I will show you how to install GraphViz. So for GraphViz, there is an installer for it. So you actually need to double click to install it. That is all. But the next video will give you more detailed explanation on how the GraphViz library is used, and you need to configure the library for part1. If you click here and then search for part1, PROCDOT, you will see part1 here. Now part1 needs to know where you install a certain file called .exe. You can see here. GraphViz, this is a dependency library which is needed by another tool called part1, which already comes with Flare VM. After installing GraphViz, you need to go to the location of the install GraphViz bin folder, GraphViz bin, and look for the .exe file. You will need to set the path to this .exe in your part1 program. Watch the video lesson on how to do this. So I will explain how to do that in the next video lesson. So that is all for this video. Thank you for watching. So in this video, I will show you how to solve this error. So proc.dot is looking for something called dot executable. So to solve that, you will need to install a library called graphic viz. So you have to go and download graphic viz from this link here. Just Google for graphic viz, download, and you will come to this link and just download graphic viz. And after downloading and installing graphic viz, you can just start your proc.dot. And when you start proc.dot, it will ask you for the path to graphic viz. Let me show you. So I'm just going to close this project first. So I'm going to run proc.dot now. Click OK, and here you have to supply the path to the .exe. So the .exe is found in this path, program files, graphic viz, bin. After you've done that, then you click OK. Now you can use your proc.dot. So in order to use proc.dot, you have to get the output from procmon. So click on this one to go to the procmon export file, which is a .csv file, and then click open it. After that, you click on launcher here, and you analyze your procmon CSV file. Once it's finished with the analysis, select the target that you are analyzing, and then click on refresh, and it will generate the interactive graph. As you can see, it has successfully generated the graph. Now before you can use the procmon CSV file, the output must be set first. So you need to open the readme file where proc.dot is installed, and then see how to configure your procmon output. This is the important step to follow. So you have to open your procmon, and then over here click on options, and then make sure you uncheck show resolve network address. This one should be unchecked. And then after that, adjust the displayed column option, select column, and then over here not show the sequence column, so you must disable the sequence column. This one, I think, yeah. And then next thing is you must show the thread ID column, and click OK. Then only you export it. Save it, all events. Under here select CSV, and then click OK. Save it. After you have saved it, then only you can use your proc.dot to open that file and do the visualization. That's all. I hope this helps you guys. Thank you for watching. Hello and welcome back. We are now going to do a practical hands-on and analyze malware sample 1 zip. Please download this from the resource section and then unzip it. The password is crackinglessons.com. After you have unzipped it, you should get a folder, and inside it there is a subfolder or malware 1, and this is the malware itself. So be careful, make sure you're doing this inside your virtual machine. And at first glance you will see that it has a fake icon, PDF icon, and it also has a .exe extension. We can clearly see this because we have enabled the show extensions. By default, Windows does not show the extension. So a casual user might be fooled into thinking that this is a PDF file. Now we are going to do a static analysis. We can use TreatNet to check the file type. So let's start TreatNet. Do not rely on the extension. So use TreatNet to confirm whether it's an executable file. And TreatNet has found that there's a high likelihood, 67% is an exe file. So we know for sure it's an executable file. Next thing we can do is use PE Studio to analyze the PE header. So we can go to Utilities folder and start PE Studio. PE Studio, as I mentioned in the previous lesson, is specially designed for malware analysis. So we drag the malware into here and give it time to let it analyze, and it is doing analysis. As you can see, there's a wait message there for some of the fields. So just let it run. It has finished its analysis. You can go straight to the indicators, and here it tells you the severity, level 1, 2 and 3. Level 1 is the most severe. So these are the indicators of compromise, and you can see here, number 1, level 1 will be the file references strings tag as blacklist, the file references blacklist libraries, the file import symbols tag as blacklist, the file exposes thread local storage callbacks, and so on. So probably the top 3, 1, 2, 3 are the main indicators of compromise. Possibility only, we cannot be sure until we go ahead and look at other tools. And then the file references strings tag as blacklist, so you can go straight to strings and take a look at the blacklist. So in the strings panel here, you can see the offset, the string type as key, and the size string, and blacklist or not blacklist. So you can click on this to toggle and show all the blacklisted ones first, and then here you can see what are the strings that it has found in this file which are blacklisted. Registry set value usually is used by malware for persistence to enable it to start whenever the operating system starts. And you also have networking, connect, socket, get host by name, WA starter are all WinSock APIs used for connecting to the network. So a PDF file should not have all these things. So this is definitely a no-no. And some more suspicious API calls: internet close, internet open, and so on. Internet open URL, get host by name. So you can see all the blacklisted is marked in a red cross. And you also see it has got this all the file operations here. And it also has create process. That means it is able to spawn additional processes. This one, create to help snapshot, in conjunction with process 32 first, 32 next, are used to list all the processes running on your operating system. Now a PDF file has no business doing that. So it's very highly suspicious that you can find this kind of thing in this malware, in this program. Another one is shell execute, very highly suspicious, enables this malware to execute other programs. And you see it is also able to post something to the internet. And over here you will see this string. This is a sign of hex encoded, 64-bit hex encoding. One of the ways in which the program tries to obfuscate its strings. Okay, so that's the end of the blacklist. So we can see a lot of things here just by looking at this. And then now we can look at the import. So this will give you even more. Here we can list it according to blacklist. Alright, so these are all the APIs that are found by PE Studio and which has been blacklisted. Open process token. Registry set value is highly suspicious. That means it's able to create registry keys, probably for persistence purposes, as I have mentioned earlier. And this one is also highly suspicious. It is able to internet open URL. That means you can connect to the internet, probably calling home, calling to a control and command server maybe, to download additional payloads. And also virtual protect. Virtual protect is used by malware to change the permission for memory, and this is usually done when you want to unpack additional code into certain parts of memory so that you can execute it. And it also has delete file, which is used by malware to delete a copy of itself after it has made a copy and put it somewhere else. And as I mentioned earlier, create to help in conjunction with process first, process next here is used to list and enumerate all the processes which is running on your computer. Normally malware does that in order to try to resist analysis. It wants to know whether you're running Wireshark, Process Explorer, x64dbg, or any of the reverse engineering and also malware analysis tools. That's why it's listing all the processes running on your computer. Alright, so we have seen quite a lot of suspicious things, indicators of compromise, as we malware analysts like to call them, or also known as IOCs. Now the timestamp here, if you click on this, you will see that this malware was created on October 14 at 4:31 p.m. 1998, but this could be a fake year because this can be changed, but it is a good indicator of the time when this thing was created. And if you click on the libraries here, you will see that there are many imported functions. This is the import over here, and this is the list of the libraries where the imports came from. So you can see here there are a lot of imports, 4 from WinINet, WinSock 2. This is a WinSock library for networking, typically used by malware for connecting to the internet. adwp is used for registry, creating new keys in the registry. Kernel 32 is generally used by all PE programs. User 32 is used for creating the user interface. So this shows the large number of imported functions, so most probably this is not packed. If it were packed, you will find very few functions, not so many like this. Alright, so just using these two tools alone, we can see quite a lot of things already. So next thing you want to do is to go and get the hash. So we can get a hash by using hash my file program. Right click on this and hash my file. So now we got a hash, we can copy the MD5 and check virus total. So the hash is a sure way of IDing a file. The file name can be faked, but the hash doesn't lie. So we head over to virus total, and then once it's open, you look for the search function here and paste the hash and hit enter, and you search the database, and you find that there are 58 out of 71 hits. So this confirms that it is malware. So 58 out of 71 antivirus has detected it as malware in the past. So the hash my file is definitely a very good way to identify the type of the class of the category of the virus in the malware itself. So you can see these are the variants: Trojan, Win32, and so on. And so this is very useful. Some files are quite big, so you don't want to upload to VirusTotal. So you can generate the hash and then search based on the hash. Then you can know. So if in future there are variations of any malware, you could also use the hash to identify using this method which I have shown you. Okay, so these 3 tools alone has yielded a lot of information into the file itself, what type of file it is, and so on. So that's all for this introduction to static analysis. I'll see you in the next one. Thank you for watching. Welcome back. In this video, I will show you the correct way to do dynamic analysis. There is a correct sequence for you to follow. Dynamic analysis workflow. Follow the sequence exactly. Number 1, start part1, then pause, and then clear the output. Part1 should be start, paused. Then number 2, start fakenet. Fakenet will immediately start to monitor the internet traffic and will intercept any attempt by the malware to connect to the internet, and then will respond with a fake response to the malware. Number 3, start rack shot, and then take the first shot. Click on the button, first shot. Now the reason why we pause part1 because we don't want part1 to capture the changes made by rack shot. Otherwise, part1 will have far too many events for you to look at and to filter out. Then number 4, wait for the rack shot to do its thing. It may take a few minutes. Of course, you must have the correct settings. The rack shot should be taking a snapshot of the C drive, the root of the file system itself. So number 4, once the first shot is complete, then it will pause by itself. Do not click the take second shot button yet. Instead, you want to now resume part1, which was earlier paused. The reason why we resume part1 is because in the next step, we are going to execute the malware. So we want part1 to monitor the malware process itself. Number 5, run the malware and let it run for around 1 to 3 minutes. And then while it is running, study FakeNet output to see what the malware is trying to do in terms of network connectivity. The malware may try to call home, like contact a control and command center, or reach out to a server to download additional payloads or additional tools. Number 6, after about 3 minutes, pause part1. So part1 by this time will have captured enough events for you to analyze later. Now number 7, we use rack shot. Go back to it, and now you click the button second shot. So now rack shot will now take the second shot and see what are the changes that has been made. The reason why we use rack shot is to compare the changes made by the malware. And number 8, the second shot should be fairly fast compared to the first shot. So once the second shot completes, click the compare button and then select compare and show output. So now rack shot will compare the first shot and the second shot to see what are the changes that has been made after the malware has started running. So once the compare operation has completed, this also should take about 1 maybe 2 minutes. Number 9, study the rack shot output. Go through it and see what are the changes that has been made to the operating system. For example, new keys in the registry has been created, or new files has been added, new folders created, and so on. Now, next step is we are going to look at part1's events that has been captured in the part1. So, in order to look at the events, we need to filter out and look only at the process which you are interested in, which is the malware itself. So to do that, we need to apply some filters. So the filters that you apply is number 1, process name. So this is what it looks like when you apply the filters over here. So you can select the type of filter from the drop down list here, and then after that select the name of the operation or the name of the process in here. So the first thing is we select process name, and then from the drop down list over here select the name of the malware. So that will, and then click add, then you will see the first filter being added. And then after that, second is you apply the operation is filter. That means from here you select, from the drop down list, select operation is, and then here select this one at a time and add them to the filter list. So first one is write file, set disposition information file. This one is used for deleting files. Malware typically deletes itself after it has made a copy and hide it somewhere. And then rec set value is the registry new key being added. Then process create is where the malware create new processes or new threads. TCP and UDP are the networking protocols. So all these are the things we are interested in to filter out from the long list of the events that part1 has captured. So once you've added all this filter, your list should be shorter. You may start off with 108,000 events, but after you apply this filter, it will be filtered out to show maybe less than 10, maybe 20 events. So this is manageable. And as you can see, after you apply these filters, you can see clearly these are all the values that has been filtered out for the various API calls. Alright, so just looking at this alone, you can see some of the indicators of compromise. But we want to go a step further. We want to visualize this in the graph view using another tool called part1. But before you can visualize it with part1, you have to configure your process monitor and export the necessary files for part1 to use. So to do that, we want to set the settings accordingly for it, and the settings I will show you in the practical itself as we do it. And I believe you've also seen the earlier video in the previous videos a few lessons ago, where you need to configure the process monitor accordingly to use the options to show the correct column. The thread column must be shown, and also certain columns need to be hidden. So if you've forgotten how to do that, please go and review the earlier video where we installed graphic viz. In that video, I showed you how to configure process monitor for exporting the correct format for part1. Next thing I want to mention is these are some of the common part1 filters. So you can see if you are going to add filter to part1, these are some of it you can choose. What we have done is we have chosen this. The one in bold are some of the important ones. Write file, set position, set disposition information file, registry, set value, process create, TCP and UDP. You can also experiment with the others by adding them if you want. And then I also want to inform you about the registry persistence. These are some of the registry keys, locations, which can allow the malware to survive a reboot of the operating system. So if a malware tries to put anything in these locations by creating new keys, then it's a sign of a compromise, an indicator of compromise. So we have the HKLM, HKU, HKCU. So keep a lookout for these new keys in these registry locations. Another thing to be aware of is the differences between 32-bit programs and 64-bit programs and how it runs on Windows. If you are running an operating system which is 64-bit and the program that you're running is 64-bit, then the DLL files will be coming from Windows System 32. For example, kernel 32 DLL will be coming from here. So the 64-bit program or malware will be using those DLLs in System 32. On the other hand, if you are running a 32-bit program on a 64-bit operating system, then the DLLs will be coming from this folder, Windows syswow 64. So this is to make it backwards compatible. That's why 32-bit program can still execute on 64-bit Windows. Next thing you should be aware of is the DLL search order. When a program runs, it will need to use APIs that are exported from the DLL files. So the DLL files are typically found in Windows or Windows System or Windows System 32, and sometimes malware will try to preempt by putting its own version of a DLL that is exactly the same as the system DLL. So it can do that by putting it in the directory, in its own directory. So this is the directory search order. Anything that is found in the directory on the left will be run first before the directory on the right. So if a program is going to run, this is the order in which it will search for the DLL. So malware may put its own DLL in its same directory in which it is running. So it will run that version of the DLL instead of the one found in the Windows system folder. So be aware of that. So if you find DLL inside the malware folder itself, and it has the same name as the Windows system folder DLL, then you know that that DLL is a fake DLL, a corrupt version of the original DLL. So that's all. I want to inform you about the prerequisite knowledge that you need to have before we start to do the practicals on the dynamic analysis. So thank you for watching. I will see you in the next one. Hello, in this video we are going to do the lab practical dynamic analysis for malware 1. But first, some precautions. Make sure you are using your virtual machine. And then, as additional precaution, you can go down to the bottom and disable the network. So go down to machine and click on settings, and then over here, network, you could actually do this. Go down here and set to host only adapter. So that will disable the network, but this is optional, right? I'm not going to do it because I'm not connecting to my local area network inside my office or anything like that, so it's quite safe. So in your case, you got to take these extra precautions if necessary. So now the first thing is we are going to follow this sequence here. Start part1 and then pause it. So go to the part1 at the bottom here, click on part1, and then once it's started, just pause it. This is the button. Click on this to pause it, and then click on this to clear the output. Second, start FakeNet. So FakeNet is at the bottom here, so just click this FakeNet icon to start it. And FakeNet will fire up and intercept all the network traffic that the malware will generate. Next, we are going to start RegShot. So just click on this to allow access. So for RegShot, open the Flare folder, the utilities folder. Inside it, look for RegShot and start it. And now here, click on this checkbox here and then change the directory. Change to C /. We want to snapshot the entire root file system. So click on first shot. Click on shot, and it is now creating a snapshot of your entire file system for the virtual machine, and this will take a few minutes, so I'll just pause the video and come back when it's done. The first snapshot is now done, and I get this message informing me. Just click OK, but don't click the second shot yet. Now we are going to start our part1. So we're going to resume part1. So come over here and click capture. So now part1 has started, and now we are going to execute the malware itself. So we are going to double click and execute the malware. And immediately you see the malware has disappeared. That means it has deleted itself. And if you look at FakeNet, you can see that it has reached out to the internet and posted something to this website, mbaqayahcn.biz, and then it is also posting to this path, UAN9BAU and so on, and it is connecting to a web server. You can see 80, the host name and the port number. So 880 is a web server, and it is posting some data, and the length is 938 bytes, and this is the key value pair. It is posting the value A, and this is some kind of encoding from here to here. So now we are going to let it run for approximately 1 to 3 minutes and see if anything else appears in FakeNet. So FakeNet is intercepting, and you can see here it is now sending another post. So FakeNet has intercepted all the internet traffic that the malware has generated and showing it in here. And the second post that is also sending is a repeat. You can see the URL host is the same, and the port is the same, and the bytes is also the same, 938 bytes. It's the same. And I think the encoding here, the data that is being sent is also the same. So it is trying to send the same data, posting it to the same server, and it has done it twice so far. So we just give it another 1 minute roughly, and then we will pause part1. Alright, so now it has sent another post, as you can see here, and it appears the length is also 938 bytes, and the host is the same, MBAQY, so on. So looks like it is trying very hard to post this data to this web server, and FakeNet has intercepted it and replied back to the malware, but probably the malware did not recognize the reply. That's why it continues to try to send the same data to the server on the internet. So that's why we're seeing 3 posts here, identical posts. So that's how FakeNet works. FakeNet intercepts the traffic and pretends to be a server, but it does not forward the traffic out to the intended server. Instead, FakeNet will reply with its own message, just saying FakeNet or something, back to the malware. And this is the 4th post you can see here. So it has posted 4 times identical packets, 1, 2, 3, 4. So now from here we can see the indicator of compromise. The host name is in plain sight for us to see over here. Alright, so now I think we can pause the process monitor. So let's pause it. And then now we can go and use red shot to take our second snapshot. and see what changes. Okay, click second shot and click shot. So the second shot should be faster than the first shot. Once it has completed the second shot, the compare button will be clickable. So let it do its job. I will pause the video and come back when it's done. Oh, looks like it's done. So click OK now. Alright, so now we can do a compare. Just click on this button here, compare, and then scroll down to compare and output, so that once it's finished comparing the first shot and the second shot, it will immediately display the output. So click on this and let it do its thing. So this one will take longer than the second shot, so I'm going to pause the video and come back when it's done. The comparison is done and this thing automatically pops up. So now we can analyze this and see what happened. So we can see here values added, and over here we can see a new key has been created. This is the key 12648,430, and this is the value of the key. It is created in this registry. S1521 is the user, which is the malware itself, and this is the software registry. And then run once, so this is the persistence here. So it's trying to create a method for it to persist. So it created a new key, this key, and here we have the actual file which will be run when the malware starts in the next reboot. So you can see it has put a new file, created a new file called ctfmon.exe in this location. So now we can know where the malware has hidden a copy, maybe a copy of itself, with a different file name at this obscure place. Okay, let's scroll down. So we have seen two indicators of compromise from this file. And let's take a look at, see if there's anything else. Okay, folders added. It has created this folder in order to put the ctfmon file in there. So this is the second indicator of compromise, same as the top one. Files deleted, so it has deleted itself. See that? And we saw with our own eyes that the file was deleted when we started running it the first time. Files added, this is the one. So it's created this new file and put it in this location, and this is to make sure that it can run. It also created a registry entry which we saw above. So we have found a lot of revealing things from this red shot. So now the next thing we do is to do the part1 filter. So let's go to part1. Click OK here. Okay, for the part1 filter, I will continue in the next video. So stay tuned. I will see you in the next video. Welcome back. We will now continue with the dynamic analysis of malware sample 1. So we last stopped here after getting all the process monitor and also the red short output. So now we want to filter out the process monitor. Without filtering, we can see there are about 221,000 events. So we are going to filter out a few things. So click on the filter here, and then the first thing is we select process name. Click on process name, look for process name, because these events are events for all the events of the entire operating system, but we are only interested in our malware. So click on process name, and down here there's a drop down list, and click on this malware, click add, and you can see it's added to the filter. And then when you click apply, watch what happens down here. Alright, it has reduced the number to 82,000. Okay, so now we are going to continue adding additional filters, and remember this diagram. These are the filters we are going to add. So next one is operation is. So we click on here, select operation is. Operation is the API calls. So the first API is write file. Filter out the write file API, and then click add, click apply, and you see it's reduced to 66. And now next one is set disposition information file. Set disposition information file is to delete files. So click add, click apply. Okay, and now next one is rec set value. Rec set value, click add, and then click apply. And the next one is process create. Search for process create. With any malware, these are the APIs that you'll be doing, that you'll be filtering out. Click apply, add and apply, and then TCP. Yes, no need to search here because there are many TCPs, so we're just going to manually type in to select all the TCPs. Click add, and then click apply, and then UDP as well. So TCP and UDP are the networking protocols. Alright, so now we can close this, and then we need to set the options. Make sure none of these are checked. Then select columns here, and then here make sure thread ID is checked, and the rest are as follows. Follow exactly what you see here for my setting, and then click OK. Now we're going to save it twice. One is in native format, click File, Save, and then select all events, native format PML, and then click on this to select the location to save this capture. Select the malware sample folder here, and then click Save. So this is log file PML. Click on Save, click OK. Alright, the reason why we save PML is in case later on you want to reopen it to re-examine. You can do it this way. Then the second format we are going to save is the CSV format. Click all events. Here select CSV. Now this version is for the next program which we are going to use to visualize the events. That is the proc. So proc requires a CSV. So here the location is the same, but the file name is a different extension. Click OK. So just wait for it to save. Now it's done. We can now open our proc.dot. So just go to the Flare folder, Utilities, and open the proc.dot program. Yeah, okay, so just click OK here. And then here, make sure you set the path to the .exe. It needs this. The windump, TCP dump is not necessary, but this definitely we need. So I've already shown you how to install GraphViz in one of the earlier video. So if you have not done this step, go and do it now. Select the path, which is this path. Click OK. And then next is we are going to open the CSV file by clicking these three dots here. And then go to the desktop where you save the log file, CSV format, part1 CSV, click open. And then now we can click on this to launch it. These three dots here, click on launch. And it will start analyzing the CSV file. So let it analyze. Once it has finished the analysis, you will see a list of all the processes. So just click on the malware itself and double click on it to select it. And then you need to refresh the output. So click on refresh. And now it will generate the analysis graph for you to visualize. And it has generated the graph. And compare this with your part1. part1 has 243 events, and it is quite good by itself, but it is too many to try to comprehend what is going on. So proc.dot takes all these events and find the relationships between them and visualize it in a graph, which is so much easier to understand. So if you want a raw output, you will look at proc1 events here. From here you can see it's writing to this file, creating some registry value here, creating a process here, and so on. But this is itself good for indicators of compromise, but to visualize it and understand, we use this. So this one is an interactive graph. You can hold down the control key and zoom by scrolling your wheel of your mouse. Zoom in and zoom out. Then you can drag and move around. And here is a budget report, the original malware itself. It has created a thread, as you can see, 2284. And then over here, it has created a process, CMD process here. And then over here, you can see at the back here, it also created a temporary batch file, 124.bat. And then this batch file was executed in order to delete something else. So you can see it probably used the batch file to create another thread, another process to kill the CMD file, and which was used to delete the batch file itself. And then over here, so it has also created a persistence key in this location, in this registry, with this new key 1264840, and this is how it starts itself when the computer reboots itself. And then what is actually going to restart this file, cdfmon. You can see the arrow coming from here. So this persistence key is going to run this file, and then this file, if you trace it, it has been actually renamed from its original name. See that? Original name is budget report, and then it has renamed it. See the dot, the dash, the label here, renamed to a different name. So now we know ctfmon and budget report are the same file. So this is how it hides itself. It hides itself in this location, and then from here it renames itself, and then and it has created some other keys as well. So those are the main indicators of compromise that we are seeing here. So if we had not used part1, we would not be able to see this kind of relationship between the various components. These components are all known as artifacts in malware analysis. So artifacts are the leftover clues or evidence that malware has existed or did something. So this collection of all these artifacts here will make up your indicators of compromise. So that's it. Those are the how important and how useful this part1 tool when used in conjunction with part1. So now, if you wanted to write a report, you will probably write a report to show all these things. List down this file. It has been renamed from a previous file, original name, and then it has created a registry entry here, and it has also created a batch file used to delete itself later on, and later on the batch file was also removed and all the registry locations as well as the location, the path of the new file. Alright, this will all be included in your report for the indicator of compromise. Now the next thing we do is network analysis. So for network analysis, I will see you in the next video. Thank you for watching. Welcome back. We are now going to continue and we are going to do malware network analysis. So this previous part1 analysis was very useful if you wanted to rescue your operating system. Now you know where to go to delete the malware from these locations and here as well. Right, so this is so useful for recovering from a malware attack, malware infection. So to do the network analysis, we have the fake net. Earlier on we saw this is indicator of compromise. It's trying to reach out to this URL and sending this encoded bytes to the server. And now the fake net also keeps a record. So we can close fake net now, Ctrl C to kill it. If Ctrl C doesn't stop it, you can just close it by closing the window. So fake net record is in here, fake net logs. If you open fake net logs here, you scroll down, you will see a pcat file down here. Now pcat file is by default will be opened by a program called Wireshark. So all you need to do is just double click it and Wireshark will open this pcat file and we can analyze it. So let's just wait for Wireshark to fire up and initialize. Okay, so now these are all the packets which was captured by fake net and stored as a pcat file, and what we want is the HTTP, because we saw from fake net just now that it was connecting to a HTTP. So we can go up to the filter box here and key in HTTP protocol and hit enter. And now from the top here you can see all the, and you can see here it's posting something to the internet, right? So this is a post request, so we can just right click this and then select follow TCP stream. So now it will reconstruct the traffic, and here you can see this is the same output we saw from fake net earlier. It is connecting to this website, is at port 80, and content type is a form. It is posting this data with this key and this hex encoded string, and the response is okay, and fake net intercepted the traffic. You can see that. Alright, and so this is a clear indicator of compromise also. Now we know where it is going to. So if you want to further analyze this, you probably can use a decryptor to decrypt this hex encoded string to find out what it is. So this is how you do a network analysis, and this is just an introduction to malware analysis. The basic steps are just like this. So just to recap what we have done for the past 3 lessons, we have done a network analysis following this procedure exactly in this order. And then we also did the part1 settings and part1 export, and we set the filters, and we saw the analysis confirm the persistence location, and we also did the network analysis using FakeNet and Wireshark and analyze it by following the stream. So hope this helps you guys out there to get a basic grasp of what dynamic analysis is all about. So now you can write the report to put in everything that you have seen, and that report will consist a list of all the indicators of compromise that you have seen. So that's all for this video. Thank you for watching, and remember, before you start your next session of your malware analysis, you should always go and restore your snapshot for your virtual machine. Okay, so restoring your snapshot will clean up all the malware from the virtual machine so that you'll be able to start afresh with a new analysis for a new malware sample. So that's all. Thank you. See you in the next one. Hello and welcome back. In this new section, I'm going to give you a lab exercise, and this video is the instructions for malware sample 2. So go and download malware sample 2 from the resource section for this lesson, and copy it into your virtual machine. The password to unzip it is, as usual, crackinglessons.com. So the password for unzipping is crackinglessons.com. So after you have unzipped, try it on your own before seeing the next video. Use the correct tool to do static analysis first. You will find that it is packed. You can use exe pe-info. It will show you whether it's packed or not. Also, you can use PE-Studio or CFF Explorer and examine the IAT table to see how many functions are imported. From the number of functions, you will find that there are very, very few functions that are imported, and that is a red flag, indicating that the malware is packed. So the exe pe-info will also give you a hint on what packer is used. So you will find that it is packed with UPX. So if it is packed with UPX, you can unpack it using UPX as well. The Flare VM virtual machine comes with UPX. So all you need to do is open a CMD command prompt and type in this command. Of course, you need to go to the folder first, and that contains the malware, and then assuming that the malware's name is called original name exe, so you need to unpack it and give it a new name. So assuming this is the new name that you are going to give it after unpacking, so this is the command upx space -d for unpacking, and then -o output file name, new name, then space original name. So after unpacking, you will find a new file in the folder call new name or whatever name you give it, and then use this unpacked exe for static analysis as well as dynamic analysis. So as usual, this is live malware, so be careful. Make sure you run it in the virtual machine and don't accidentally click it in the host machine, and only unzip it in the virtual machine. Do not unzip it in the host machine. This is additional precautions for safety in case you accidentally run it. And if necessary, you may want to set your virtual machine network to host only mode. So if you are running this in the office environment or where in a local area network in your workplace, you might don't want to infect the company. Anyway, this is not a worm, so don't worry, it will not transmit itself through the network, even if you don't set it to VM host, to host only mode. But if in future you are analyzing an unknown malware, then you might want to take these additional steps to protect yourself from worms. So okay, with that I leave it to you to go and do the exercise, and then I'll see you in the next one. And please make an effort to try on your own before you watch the rest of the videos on how I do it. Thank you for watching. See you in the next one, and good luck. Welcome back. We are now going to start a new lab session to analyze malware sample number 2. Go and download this malware sample and unzip it. The password to unzip the file is crackinglessons.com. After unzipping, open the folder, and this is your malware sample inside here. As you will notice, it takes on the Excel icon, and it has got a double extension. A casual user will not see the real extension because the default setting for Windows will be to hide the extension. He or she will only see the XLS and the icon and will be fooled into thinking that it is an Excel file. So the first thing we do is to analyze it with TreatNet. We will open up TreatNet and see. TreatNet is used for identifying what type of file it is, whether it's an exe file, a zip file, or DLL file, or anything else. And you can see straight away it tells you 55% it is UPX compressed, and we can run p another tool to confirm it. Let's open the utilities and look for exe pinfo. And we now analyze it with exe pinfo, and it says it is packed with UPX. And then it even tells us how to unpack it using the command upx-d. So let's unpack it now. Copy this path here, right click and copy, and then open your command prompt. And then navigate to the folder which contains your malware. Type cd space, and then right click to paste the path that you have copied earlier. Hit enter and it will change directory. Just type the dir command to confirm that we are in the correct directory, and you can see the name of the malware here. To unpack the file, we use the command that Treat suggests. So the command is, I also gave you the tips in the previous video on how to unpack it. So take a look at the notes from the previous video. The unpacking command is upx-d for decompress, and -0 for the output name, and then the name of the file, the malware itself. So let's try this now. So to uncompress, to unpack it, we use the upx command. If you just type upx without any parameter and hit enter, it will give you the help. So let us clear the screen, CLS. You can see here -0 is the output file name, and -d is decompressed. So let's clear the screen now. We know how to use it. upx -d to decompress, and -o, what is the new file name that you want to give it. So we'll call it financials unpack.exe. Next, we put a space and we type in the name of the malware itself. So this is a command line to unpack the malware and to save it as a different file called financials unpack. So after running this command, you should have a new file in here. So just press enter. And then you will see it has unpacked the file and save it as a new file name. So this is the new file that we have got. And now if we were to run treatnet on the new file, let's try and see. And you see that it doesn't say upx packed anymore. Instead, we get a report saying it's a Win32 executable, Microsoft Visual C++. And then if we check it with ESCP info again, and now you see the unpacked file doesn't say that it is packed anymore. So we are ready to proceed to the next stage of the static analysis. So for that, I'll see you in the next video. Thank you for watching.